Hello all and welcome to the video for Algebra Lesson 5, which is going to focus on Chapter 1, Section 6. We are skipping Chapter 1, Section 5. Various reasons for that, but we are skipping a section. So Algebra Lesson 5 is going to be Chapter 1, Section 6, which is on what we call relations. Okay, so this is on starts on page 42. And before we actually get into the meat of the section, there are a various number of definitions that we need to cover, okay? Some of these are going to be maybe a little bit of review, especially on this first page here. But tons of definitions, but as we get into the examples, you'll actually be pleasantly surprised. These questions are actually some of the easiest in algebra if you really know what you're doing, okay? So relations. In order to talk about relations, we need to review a couple things, okay? And one of those things being the coordinate system, okay? So if you look at the notes here, we have a coordinate system. And the way we define the coordinate system is it is an intersection of two number lines. Okay, everybody in algebra should know what a number line is. Okay, if you don't know what a number line is, probably have some problems, but please let me know so that way we can get you to understand what a number line is, okay? But the intersection, well, what does it mean when two things intersect? Well, what's an intersection in a road? It's where two roads intersect, okay? So it's where they cross. So the intersection of two number lines, one being horizontal, which we call the x-axis or horizontal axis or x-axis, and the vertical axis, which we normally call the y-axis, okay? On the next page, we'll actually do a representation of all this. So get through the definitions first, and then we'll go through and talk about each one of these in its entirety in terms of give you an example of everything here. So now when we talk about x and y, so x-axis and y-axis, okay, this leads us into the next definition of what we call an ordered pair, okay? An ordered pair is a collection of numbers or coordinates, okay? So if you're familiar with world geography, reading maps, talk about coordinates of longitude and latitude. Well, basically, an ordered pair is kind of like longitude and latitude. It gives you coordinates to tell where you are in the coordinate system, okay? So you can kind of think of the coordinate system as kind of like a map, and the ordered pair is telling you where you are on the map, okay? And it's always written in the form x comma y, where the x, so the x value that we're talking about is the first number, comma, y the second value after the comma, okay? So that's where we get the terms x-axis and y-axis. The x and the y come from that. Well, why is it x and y? Well, that's what we talk about next with the x-coordinate and the y-coordinate. So the x-coordinate, which is the number that's here in the front of the ordered pair, which is also given by its position on the x-axis, represents the horizontal placement of the point, okay? So what that means is basically when I say horizontal, it means how far left or right do I go, or in case of like a map, east or west, okay? So once again, that's telling us horizontally how we go. Well, the y-coordinate is kind of the opposite. It represents the vertical placement of the point we're talking about, okay? So in that case, we're telling how far up or down we go, okay? Or in terms of an actual map, north and south, okay? So x-coordinate tells us left or right. Y-coordinate tells us up or down, okay? And that's what these numbers here represent. So x and y, and that's what the x and y axis are. That's why the x-axis is the horizontal axis, so left or right, and the y-axis is the vertical axis, up and down. So I can sit here and talk about definitions and words and all that, but let's actually look at an example of a coordinate system, okay? So first off, we have coordinate system in terms of, if you look horizontally here, we have a number line, okay? Well, how do we know it's a number line? Well, we would label it. So here we have 0, okay? I want to hold off on labeling 0 right now, though, but here we have 0. Here's 1, 2, 3, 4, 5, 6, and so on and so on. 7, 8, 9, 10. Okay. 11 if we needed to even go this far. So I made this way too big probably, but we'll keep going. Okay. 13, 14, 15. Okay. And you can actually keep going on and on and on. Okay. So that's what this little arrow means out here. You keep going on and on forever. Okay. Pretty much forever. So in this case, you just keep going. So you can go to 16, 17, 18, 19, 20, 1,000, a million, 200 million, 59 trillion. Okay. Once again, as long as you can keep going on the number line, that's what that arrow means. Okay. Well, if you know the number line, if you go in the left direction, this is actually where we get the negative number. So once again, I'm going to hold off on 0 for a second, but we have -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12, -13. So it's kind of a little bit lopsided there, but that's the thing. Normally, you like to have your uh, coordinate system centered, but just to fill these numbers in really quickly. Once again, just like a normal number line, -13. And actually, if you keep on going, there's an arrow here that tells you if you keep on going that way, okay, then you will end up, keep on going. You go to -14, -15, -16, on and on and on. Negative a million, -200 million, -59 trillion, negative whatever number you need to go to, okay? Hopefully you don't need to go to that big of numbers, but once again, you can just keep going and keep going, okay? But then, once again, we got this 0, but I want to hold off on it still yet because I want to talk about the vertical axis here, okay? Once again, horizontal axis, this is what we call the x-axis, okay? Well, this vertical axis right here, this is what we're going to call the y-axis, okay? So y-axis, okay? So once again, it's a number line, kind of just flipped a little bit, okay? So think about this horizontal number line. What if you turn it and make it point up and down? Well, then you would have what we call the y-axis, okay? So once again, if we go, the only thing is we have to say which way do we go with the negatives, which way do we go with the positives? Well, on the y-axis, we go up for positives. So 1, 2, 3, 4, 5. This is a little bit nicer. There's not so many numbers here. 6, 7. Okay. Well, if you go up in the positive, that means down is negative. So here you have -1, -2, -3. Oh, so it should be a -3. -4, -5, -6, -7. Okay. And once again, arrows on top and bottom mean this goes on forever. So you can go up and up and up to 8, 9, 10, 11, 12, a million, 59 trillion. Okay, I know I keep using that number, but once again, you can go as far as you need to. Okay. And the same thing, you can go -7, -8, -9, -10, -59 trillion. Okay. So that's the thing. You go basically infinitely in any direction. So basically you can just make this as big or small as you need to. Okay. Now, to go back, I want to talk about this middle part right here. Okay. And normally when you see me write it, I always write it with a circle around it. Circle, or you can think of it as the letter O, because this place right here is what we call the origin. Okay. So that's what we call the origin. And what this represents, if we're thinking about this in terms of the x and y coordinates, this is the point, or this is the ordered pair, 0, 0. Okay. Once again, it's 0, 0 because that's where we start. We start right here because what is this on the y or x-axis? Well, if you think of this number line, that's where 0 is. So that's why the x coordinate is 0. Okay. Well, think of it on the y-axis. Where are you on the y-axis? Well, if you turn your head and look, you're at 0 there too. Okay, so that tells you you're not going 0 up or like you're going 0 up or down. You're not anywhere. You're right at the start. Okay, and once again, we call it the origin because once again, this is where you start. And you'll see what I mean once we actually go in and make a point, which I'm getting ready to do right now. Okay. So once again, there's the origin. And now let's talk about these points in another ordered pair. So let's say we have the ordered pair 2, 3. Well, how we would represent that is we would start at the origin and we would go 1, 2 in the positive since it's a positive 2. And then we would go up 1, 2, 3. So this point right here is going to be the point 2, 3. Once again, it tells us we're horizontally over 2 and we're vertically up 3 because both of these are positive. If we have negative numbers, if we had, let's say, the -2, -3, well, that would mean we go to the left 2 since it's negative and down 3 since it's also negative. Okay, so this would be the point -2, -3. Okay, and once again, we're going to use this to plot a bunch of points. This is important for later because one of the things we're going to be doing later is graphing equations, graphing functions, okay? So we need to know what the coordinate system is and how it works. Now, later on, we'll be using a lot of the graphing calculator, so that's something we'll go into here in the coming weeks in terms of learning how to use the graphing calculator, learning how to plot points, learning how to graph equations, all that kind of stuff. But this, when you graph something, this is what you use to graph things, okay? And this is, once again, this is what we call the coordinate system or the coordinate plane. Okay, once again, you think of it as a plane, not a plane like you fly, but a plane in terms of like a flat area, kind of like a map, okay? Once again, it's kind of like a map where the coordinates or the ordered pairs tell us where we are on the map, okay? So if we're at the point 2, 3, that means we go from the origin over 2 and up 3. So to the right 2 and up 3. If we have -2, -3, that means we go to the left 2 and down 3, okay? So keep that in mind as we go forward because that's going to be very important for what we're going to be doing later on, okay? So a little bit of review there for you, all right? And you definitely need to know this. It's one of the big things in algebra that you talk about because, like I said, we do so much with it later on when we graph. We're even going to learn how to graph inequalities on a coordinate plane, okay? So it's very important you know how points work and what this means in terms of ordered pairs, x-axis versus y-axis, where the origin is, okay? Just know your way around the coordinate plane, okay? And it's going to show up actually here in just a few seconds when we look at, or in a few minutes when we look at the first example, okay? Let's go ahead and do some more definitions, okay? So that's some review there for you. So now we're getting into stuff that maybe either you haven't seen before, or if you have seen before, it's something maybe that it's been a while or something you maybe forgotten, okay? So the first definition on this page that we got to do is, what is a relation? Well, that's what this whole section is about, okay? And a relation is what we're going to call a set. So notice this right here. So I'm going to talk about that here in a second. A set of ordered pairs, okay? So all these ordered pairs we talked about, once again, if we go back, these things right here are ordered pairs. We're talking about a set of ordered pairs. And I do want to point out, I've underlined the word set here, drawn a little arrow. If you see the word set in math, as you'll see when we go down through here, you see the word set, that means you need to use braces, okay? And you'll see what I mean here in just a few seconds when we look at an example of a relation, okay? But you use braces. And once again, that tells you you have a set. And then what's going to be inside those braces are ordered pairs, okay? So once again, I'm going to go over some definitions here. It'll become very clear what I mean by that when we look at an example, okay? So that's something you probably never heard of before. So basically brand new definition for you here, okay? Now, the next definition is a mapping. Once again, another definition you probably aren't familiar with, okay? So what a mapping does is it pairs what we call, so elements, so just numbers in this case, it pairs numbers or elements of the what we're going to call the domain. Now in this case we're talking about terms once again you're going to define later on, but if you'll just follow along with me. A mapping pairs elements of the domain with elements of the range. Well, what is the domain and range? Well, that's the two next things that we talk about here, okay? And then domain and range are very similar, though. So just got to remember a couple differences here, because when we talk about the domain, this is the set. Okay, once again, set being there, set, so braces of x coordinates of the ordered pairs. So basically, you take the x coordinates, so the first number of every ordered pair, and put them in braces, and that's your set of x coordinates. That's what we call the domain. Well, if the domain is a set of x coordinates, well, then the range is what we're going to call the set, once again, braces here, of y coordinates of the ordered pair. So in this case, we're looking at the numbers like 3 and -3 here. So they're the y coordinates, once again, telling us how far up and down we go on the coordinate plane. So now when we go back and look at mapping, we take elements or numbers that are in the domain and pair them with elements of the range. Well, what's going to cause that pairing is the ordered pairs. If they're in the same ordered pair, that's how we pair them together, okay? But once again, talk about all these words, talk about definitions, all that. Let's look at an example, okay? So let's look at the example of the relation, okay? So relation, once again, a set, meaning brace, and then what's inside is ordered pair. So we have -2, 4, comma, and then we have another ordered pair, -1, 4. Have another ordered pair, 0, 6. We have another ordered pair, 1, 8. And we have another ordered pair, 2, 8. And then we close the brace. So this is what we call a relation. It's a set, so meaning we have the braces, and then what's inside are ordered pairs. So 1 ordered pair, 2 ordered pair, 3 ordered pair, 4, and 5. So it's 5 ordered pairs in this relation, okay, or this set of ordered pairs. Let me make that 6 a little cleaner so people don't get confused and think it's a B. Okay. There we go. That's a little nicer. Okay. So relation. So that's a relation. Well, before we do a mapping, which is the next definition we did on the last page, let's go ahead and talk about domain and range. If this is the relation, well, what's the domain going to be? Well, once again, it's the set, so it's a set. So we use braces here of the x coordinates. Well, what are the x coordinates? Well, if we look at each ordered pair, the x coordinate is the first number in each ordered pair. So it's -2, -1, 0, 1, and 2. Now, this just happened by coincidence, really, which normally when you do the domain and range, they don't have to be in numerical order, but actually it doesn't hurt. I mean, if you feel comfortable in arranging these in order from least to greatest or greatest to least, you can do that. But as you'll see in later examples, we can have whatever order we want to here. We can just have all the numbers jumbled up. It actually doesn't matter as long as each one of these numbers is in the domain, is in the set, okay? So once again, we'll talk more about that later. I don't want to confuse anybody, but all you do is basically go through and list all the x coordinates. That is the domain. But once again, we have to use braces because it is a set. Much like the domain, the range we find similarly, except for it's going to be the y coordinates. So it's going to be 4. But here's where, and this is what I got this little star down here for, here's where we run into the first little issue with domain and range. And this is the big thing you have to remember with domain and range, and in turn, looking at mappings, okay? So I'll make a big note of this at the end. But look what the next number in the range is. So we have 4. Well, what's the next number? Well, it's also a 4. Okay? If you have a number that repeats, you actually only write it one time. So I'm only going to write 1 4 for the range, even though there's 2 4s here, because once again, if we know a 4 is an element of the range, it doesn't make sense. I mean, in this case, if we wrote it again, that would just be what we call redundant. It would mean it's extra. We don't need that extra 4 there, because all we're looking for with the domain and range is what numbers are in the domain, what numbers are in the range, okay? Well, 4 is in the range already. We don't need to write it down again, okay, because we already know 4 is in the range. So in this case, we have 4. The next number we'll actually write is 6. And then we have the same problem with the 8s. We have an 8, so let's write 8, but then we have another 8. Once again, it's already written down. We don't have to write it again. So actually, our range is actually just the numbers 4, 6, and 8. Okay? So once again, no repeats. Now, I do want to be clear on this, no repeats here, but the same thing goes for the domain. If we had numbers that repeated in the domain, okay, we would actually not repeat the numbers in the domain, okay? And that'll come in later when you look at some examples and when you do some practice, okay? You'll definitely see, once again, if you're talking about domain and range, you do no repeats. And that's what I'll mark down here when we do the final note on this slide here, or this page. But that's the thing, no repeats. So -2, -1, 1, 0, 1, 0, 1, 2. Once again, that's all the x coordinates, but then the range is just 4, 6, and 8, because we have 4. We don't need to write 4 down again. 6, 8. We don't need to write 8 down again. Once again, if there's any repeats, you only list the number once. Okay? Now, this is important because now let's look at the mapping. So the mapping you make by making a little oval. Okay? This oval is going to represent the domain. And most of the time you see it written with a little X on the top, so you'll just normally see an X, as you'll see later on. And then you draw another oval, and it represents the range, which once again, most of the time you'll just see a Y over it since it's the Y coordinates. And all you do is you go through and you list the numbers out. So you have -2, -1, 0, 1, and 2. Well, the other side of the range. Once again, even though there's 2 4s up here, since the range only has 1 4, we're only going to list 4 once. 6, and only going to list 8 once. Now, how it pairs the elements together, the numbers together, is we use lines or arrows. So if we look at the ordered pairs, if we're going from -2 to -2, we're starting at -2, well, it's going to be paired with 4. So we draw a line from -2 to 4, or an arrow line to -2 to 4. Well, we go down to the next one. What's -1 mapped to? That's technically why we call it a mapping. What's -1 mapped to? Well, -1 is also mapped to 4. So we would take -1 and we would also draw a line to 4. Okay? 0 is mapped to 6. 1 is mapped to 8. And 2 is mapped to 8. Okay? So in this case, where the repeats come in is look how many lines are here that go to the number 4. Well, we have 2 lines. So basically, each one of these lines, each line represents an ordered pair. Okay? So we have the ordered pair -2, 4, since there's a line connecting -2 and 4. And the same with -1, -1, 4. 0, 6, 1, 8, and 2, 8. Okay? But once again, it's very important that we don't have repeats. So that's what I'm saying down here in the very last thing is do not repeat numbers in the domain and range. Once again, it serves no purpose, and I'll go ahead and warn you in terms of any assignments, any practice, homework, anything like that. Your answers will be counted wrong if you repeat numbers in the domain and range. So just be aware of that. That's probably the hardest thing about this section is remembering that when you write out the domain and range, you do not repeat numbers, okay? So if the 4 shows up more than once, if it shows up all 5 times, that means the range would only be 4, okay? So once again, just pay attention to the numbers. If you have a number represented more than once, even if it's represented every time or just 2 times, okay, you only ever write it once. So basically, you see a number, you write it down. If you see it again, you basically ignore it. You say, hey, all right, I already have a 4, so let's go to the next one. 6, 8. Let's go to the next one. Oh, well, let's ignore that. So that's it. That's all we have is the 4, 6, and 8, okay? And then the mapping, once again, we use the domain and range to make our ovals, or sometimes I call them blobs. Make an oval here and an oval here, and then basically we just draw lines between the numbers that have a connection, meaning that they have an ordered pair together. So -2 and 4, that has the line, okay? So if we go on, let's do one last thing before we look at an example, okay? And let's look at different representations of the same relation, okay? Now, a couple of these, as you see here, table and graph, I'm kind of relying on you knowing what a table is, and then based on what we've just done at the beginning, knowing how to graph things, okay? So let's show how we can write a relation in different ways, okay, and have the same information. So what I mean by that is, well, if we had ordered pairs, the relation looks like this. Once again, a set. Well, we have, let's say the ordered pairs 1, 2, -2, 4, and 0, -3. So I did that a little backwards with the parentheses. But that's what a relation looks like if you write them out as ordered pairs. Once again, a set of ordered pairs, okay? Well, this same information given in table form, okay, well, you just go through and make a table. One column X, one column Y, where the X and the Y for each ordered pair is each row. So this first row we can write as 1, 2. We can write the next one as -2, 4. Which, let me fix that negative on that 2. That looks a little weird. There we go. -2, 4. And then the last one, 0, -3. Okay, and that's a table. But notice here I did put an or because it actually doesn't matter what order you put the rows in. Now, I do want to be clear. The 1 always has to go with the 2 here because 1 and 2 are in an ordered pair. That means 1 and 2 have to be in the same row. But let's say 1 and 2 are at the bottom. As long as the 1 and 2 are with each other, we can put the rows any way we want to. So let's say we had it like this. Okay, these two tables say the same information. Okay, it's telling you your x's are 1, -2, and 0. Well, same thing down here. Your x's are -2, 0, and 1. Okay, same thing. Your y's are 2, 4, -3. Well, here they're 4, -3, and 2. Same information. And then the most important thing is, once again, the 1 is still with the 2, the -2 with the 4, 0 with the -3, -2 with the 4, 0 with the -3, 1 with the 2. And this is probably the easiest one to represent, just drawing a table. As long as you have the ordered pairs here on each row, that's pretty much it, okay? It's telling you the same information. It's telling you have the ordered pair 1, 2, the ordered pair -2, 4, and the ordered pair 0, -3. Getting a little bit tougher, but still should be pretty easy, is the graph. And when you graph a relation, all you literally do is plot the ordered pairs. Okay? So once again, if we label this, we have 1, 2, 3, 4, 5, 6, 7, -1, -2, -3, -4. Ooh, that wasn't nice. -4, -5, -6, -7. And technically, we didn't have to go out this far, but just to be consistent and label everything. 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. So where's the point 1, 2? Well, we start at the origin, and we go to the right 1 and up 2. Okay, so that's a representation. That's the point 1, 2. Okay, and you can label these, or you don't technically have to label these. If you just put the point there, it's understood that that's the point 1, 2. I'm just labeling here for your all's convenience. Okay, -2, 4. Well, the -2 tells us we go to the left 2, and then the +4 tells us we go up 4. So that tells us we have this point right here. Okay, which once again is -2, 4. And then lastly, we have 0, 3, -3. So in this case, 0, well, if we start at the origin, the first number being 0 tells us we don't move left or right. We stay at 0. And then we go, since it's a -3, we go down 3. So we have this point right here, which is the point 0, -3. Now, one big temptation everybody has, okay, this is actually it. That's all you have to do. A lot of people, they want to connect these dots. So they want to go down and connect these dots for whatever reason, okay? Well, we're not to that point just yet. So whenever you draw a relation like this, if you just got a bunch of points, you just leave them as points, okay? We're going to talk about when we can connect dots in the next section when we talk about functions, okay? So don't get the urge to try to connect these dots, because actually, how would we connect them? Would we go here, 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 or would we go to -2, 4 to 0, -3 to 1, 2? How would we do it? Okay, and that's the thing. So we don't know how we would do it, so just leave them as points. Okay, so I'm going to put a little thing here. Don't connect the dots. Okay, so don't be tempted to try to connect them or link them up somehow, because that's not what this is about. This is just representing these ordered pairs on a graph. Okay, once again, if you look at this graph, you see those ordered pairs. That's the same thing that you get up here, same information. Okay, all right. So last thing is a mapping. Okay, but before I do a mapping, I always like to figure out what the domain and range is. Okay, so if we go back and look at our ordered pairs, what are the x-coordinates of our ordered pairs? Well, we can look at this a bunch of different ways. We got 1, -2, 0. Well, you can see we got 1, -2, 0, -2, 0, 1. If we look here, we've got -2, 0, and 1. So basically it's telling us what x-coordinates have points, okay? However you want to look at it, the domain is going to be the same every time. It's going to be, okay, 1, -2, and 0, or -2, 0, and 1, or whatever. It doesn't have to be in this order. Just as long as those numbers are there, that's the domain. The range in this case, once again, we would go back and look at the y's. 2, 4, -3. 2, 4, -3. 4, -3, 2. Okay? -3, 2, and 4. Once again, it's telling us what y values have points. So it would be -3, 2, and 4. Which, once again, it doesn't matter the order we put them in there, so I'm just going to put them in there as 2, 4, -3. Okay, so if we do that, we know the domain and range, then the mapping's super easy, because all we do is list out 1, -2, 0, and then 2, 4, -3. So let me drop that 4 down a little bit, make it even. Okay? And then all you do is once you have your domain and range labeled out is you draw lines between the points that have a connection. So let's say we're going from -1 or 1 to we'll go from 1 to 2 because we have the point 1, 2. This is going to be a pretty boring mapping, but here we go from 1 to 2. Well, what does -2 go from? Well, -2 goes from -2 to 4. Okay, you're mapping -2 to 4. And then what's the 0 go to? Well, then 0 goes to -3. Once again, you see I wrote this OR here because what if we ordered these a little different? What if we had -2, 0, and 1? But we kept these the same over here. So 2, 4, and -3. Well, in this case, it still works the same way. What number goes with -2? Well, in the ordered pairs, the -2 goes with 4. What goes with 0? Well, 0 goes with -3. Well, what goes with 1? Well, 1 goes to 2. So even though the lines crisscross and all this different stuff, if you follow the lines, that tells you what the ordered pairs are. So you have the ordered pair -2, 4. You have the ordered pair 0, -3, and you have the ordered pairs or ordered pair 1, 2. Okay, and both of these things say the same thing. Once again, the order does not matter. What matters is where these lines are going. Okay, the lines. So if it goes from -2 to 4 over here, it has to go from -2 to 4 over here. Okay, so just be careful when you're dealing with mappings. One, remember the domain and range, and don't repeat numbers. Here we didn't have any repeats, but don't repeat numbers in the domain and range. And when you're making the mappings, once again, order does not matter. We can shift these numbers all the way around, just as long as the domain is in this blob, the range is in this blob, and once again, we match the numbers in the domain with their appropriate numbers of the range. Once again, and that's told to us by the ordered pairs. Okay. So let's go ahead and go into example 1. And once again, basically example 1 is going to work like what we just did. Okay, so this is about representations of a relation. So they give you the relation. They tell you, express this relation, which has 4 points. So we have 2, 5, -2, 3, 5, -2, and -1, -2. Okay, and then we want to represent it as a table, a graph, and a mapping. Well, once again, the table's super easy because we can just run down the list here and say, okay, we have the point 2, 5, so the x is going to be 2, the y is going to be 5. The x is going to be -2, well, the y there is 3. The x is going to be 5, well, the y has to be -2. And then we have an x of -1, and we have a y of -2. Now notice here, when we make a table, we can have repeats. So notice the -2 repeats here. The tables, it doesn't matter. We repeat just as long as each point is represented by a row. So 2, 5, -2, 3, 5, -2, -1, -2. So that's a representation of a table. Okay, so table, check. Graph. Well, once again, we go through here. Let's label this real quick. 1, 2, 3, 4, 5, 6, 7, -1, -2, -3, -4, -5, -6, -7. I feel like I've spent most of my time in these notes just labeling this. I should have did this before, but too late now. But once again, just labeling like we've done before. So -1, -2, -3, -4, -5. Okay. So same kind of thing here. We have our graph, or we have our coordinate plane. Let's graph these points. So the point 2, 5 would be to the right 2, up 5. So we have this point. Okay. -2, 3 to the left 2. Okay. +3, up 3. Once again, it matters whether the numbers are positive and negative because that tells you whether you go left or right or then up and down. Okay. 5, -2. 1, 2, 3, 4, 5. -2, we're going to go down 2. and then -1, -2. So we're going to go to the left 1 and down 2. Okay, so there's our points. In this case, I'm not going to label them because, once again, if you see the point here, if you just know how the coordinate system works, that's the point 2,5. That's this point right here, okay? And once again, I'm not connecting the dots here, okay? You're just plotting the points. Like I said, we don't have any reason to want to connect these dots at this point. That's what we're going to do in the next section. We're going to figure out, well, what makes it to where we can connect the dots, okay? So, once again, this is the graph. That's it. That's all you got to do is plot the points. Now, if you'd like to, you can label them. In this case, I'm not going to label them because, like I said, I want you to see you can literally just plot the points because, once again, if you know how to read the points, this is the point 5, -2. Once again, 5 to the right, down 2. So 5, -2, okay? Once again, you can read what the points are by just looking at where they are on the graph. And then lastly, the mapping, okay? So if we look at the mapping, this is once again kind of that's why I put the mapping over here with part B, because if you look at part B of the question, it says determine the domain and range of the relation. Well, you need to actually determine the domain and range before you do the mapping, okay? Because the mapping relies on you knowing what the domain and range are. So if we look at the domain, we look at the x values. Well, we go down through there, okay? We go down through there. Well, we have an x value of 2, x value of -2, x value of 5, and an x value of -1. Once again, they don't have to be in any particular order. This order's fine, okay? Well, the range is going to be, well, we have 5, we have 3, we have -2. We have another -2. Once again, I'm just pulling this from the ordered pairs up here, or the table, or the graph. 2, -2, 5, -1, 5, 3, -2, -2. Okay, so we have to be careful here. That means we only list the -2 once. So that's actually the entire range. So when we make our mapping, our domain is 2, -2, 5, -1. Whereas our range, once again, it actually doesn't really matter what order we put them here, but I'm just going to put them in the order we wrote them down here. 5, 3, and -2. So now we go through and we look, well, what goes with what? Well, the 2 goes with the 5 because we have the point 2,5, okay? So again, 2,5. The -2 goes with the 3, okay, because we have the point -2, 3. The 5 goes with the -2. So once again, we draw an arrow from the 5 to the -2 because we have the point 5, -2. And then lastly, -1 goes with 2 as well. So that means we have the point -1, -2. And once again, notice we didn't repeat the -2. How we know there's a repeat is look how many lines are going to the -2. That means we have 2 ordered pairs with the y-coordinate of -2, okay? Because once again, each one of these lines is a ordered pair. 2, 5, -2, 3, 5, -2, and -1, -2, okay? So that's pretty much it as far as relations go and representing them, okay? So pretty straightforward, pretty easy, not much math involved in terms of calculation or anything like that, if you think of math in that way. But, I mean, definitely math. I mean, this is a math subject, but that's pretty much it. If you can take a set of ordered pairs and write them all these different ways, that's what you're going to have to do, okay? Now, the next part of the notes, and this is the last part, so we got this and then one more example. I know this video is kind of maybe running a little long here, but got 2 other things to talk about here, and then we got another example, and then we'll be done with this section, okay? So, next thing we got to talk about is, well, if we're talking about a relation, we're talking about the variables x and y, okay? Well, I'm sure everybody in here has heard of independent and dependent variables, okay? Well, in terms of the relation, which is going to be the independent variable, which is going to be the dependent variable, x or y, okay? Well, the independent variable, the definition they give in the book and the definition we're going to give for independent variable here is it is the variable represented by the domain, and it's usually represented by the letter x. That's why we have x-axis. We have the x as the first number in the ordered pair, okay? So in this case, the independent variable is going to be the x. Well, a dependent variable, once again, if that's the independent variable, the dependent variable is going to be the variable represented by the range. And once again, that's going to be given by y, okay? So we're going to have y here because, once again, that's the variable we use to represent the range. That's the y coordinate on the y-axis, okay? And that's what we're going to call the dependent variable. So the way that you tell the difference between independent variable and dependent variable is this little line down here, okay? And notice it's written a little funny, but if you follow along with me, it makes it super easy to tell when you're in a situation whether you have a dependent variable or independent variable, okay, or which is which. So the dependent variable depends. So notice, dependent variable depends on the independent variable. And the reason I got in or in capitalized here is that prefix on a word means not. So if it's independent, it's not dependent, okay? So think of it this way. The dependent variable depends on the independent variable, something that's not dependent, okay? And if you keep that in mind and use this word depends, okay, that will help you in all the questions that you have to do with independent and dependent variables. So let's go ahead and look at a couple or an example here. There's technically two parts, but after this we'll be done here. Okay, so real world example number 2: independent and dependent variables. Identify the independent and dependent variables for each situation. Okay, so they give you they're going to give you a couple of real world situations here, and you got to tell, okay, first off, what the variables are, and then also which one's independent, which one's dependent. So let's look at part A, talking about a dance here. So they say the dance committee is selling tickets to the fall ball. The more tickets they sell, the greater the amount of money they can spend on decorations. So if you're looking at this situation, there's two variables here, okay? Well, so when we talk about variables, there are things that can change. Well, what two things can change here? Well, they can change how many tickets they sell. So tickets sold, okay, is one of the variables, okay? The tickets sold, okay, can change. They can sell a lot of tickets. They can sell little tickets. They can sell no tickets. They can sell out. They can sell all the tickets, okay? So that is one of the variables, okay? Well, what's the other variable? Well, what's the other thing that can change here? Well, how much money they can spend on decorations. So in this case, the other variable is the amount of money, okay? So these are the variables. Okay, so what we have to do here is we need to figure out which one of these is dependent on the other. So which one is independent, which one is dependent, okay? So you got to think logically here. Which one depends on the other, okay? Well, once again, if you think about it very carefully, how much money they're going to have to spend on decorations depends on how many tickets they sold, okay? So since the amount of money depends on the tickets sold, this is the dependent variable, where this is, once again, if it's not dependent, it's independent. Okay? So that's how we figure out whether it's independent or dependent. Which one depends on the other? So amount of money depends on tickets sold. So number of tickets sold. And that's how we figure out which is independent, which is dependent, okay? Now let's go on to the next one. So part B. Now this one's a little bit trickier. Movies. Generally, the average price of going to the movies has steadily increased over time. So what are our variables? Well, what are the two things that can change here? Well, one of the things that can change is the price. So the price of the movie tickets or price of going to the movies can change. Okay? It can go up, it can go down, okay? It can change. It's a variable, okay? Well, what's the other variable? And this one's the tricky part. What's the other thing that changed here? Well, time changes. Time is actually always changing. So when you see time in a question, usually it's going to be a variable because it always changes. Time always changes, okay? So in this case, price and time, well, which one's going to be independent and which one's going to be dependent? So which one depends on the other? Okay, well, in this case, there's one way you can really think about this. Does time depend on anything? If the price of movie tickets goes up, does that stop time? Does that make time go backwards? Does it make time go faster or slower? Well, no, okay? So time, basically by definition, and this is something I'll elaborate on here in a second, is time is almost always the independent variable. Okay? Is almost always the independent variable. Whereas in this case, if time is the independent variable, that means the price is the dependent variable. Because once again, let's talk about it in terms of what's going on up here. The price of going to the movies depends on what time you went to the movies. If you went to the movies in the 1920s, you probably were able to go to a movie for a nickel. Okay? If you go to the movies now, you're basically going to spend $15, $20 to see a movie. Okay? So in this case, the time tells what the price is. So the price depends on the time. So price depends on time. Okay? Price depends on time. So one big thing, though, with this example, and I'm glad they gave this as an example, is in general, okay, now there are situations where this isn't the case. This is why I'm wording this very carefully here, okay? Time is almost always, well, be nice if it wouldn't glitch out when I'm trying to draw here, okay? Almost always the independent variable. Okay? And this is because nothing that we know of changes time. Time doesn't depend on anything, okay? Time goes on whether the price of movies is big or small, okay? time goes on, no matter how many tickets you sell to the fall ball, okay? Time goes on no matter how many math problems you work, okay? So in all those cases, time is always the independent variable. And I do say almost always because, once again, if you're interested in knowing what situations time would be a dependent variable, we can talk about that outside of class because that's a more philosophical science physics question, okay? But once again, in our cases, when we're dealing in math, most of the time, time is the independent variable because nothing changes time. A lot of things depend on time, like the price of movie theaters here, okay? So just keep that in mind as you go through and do the practice, okay? If you see time as one of the variables, or you can identify time as one of the variables, it's a pretty good chance that it's an independent variable, okay? So basically, if you see time as a variable, you're pretty golden if you just guess that it's independent, okay? So I'm kind of giving you a little tip off there. Time is independent in our cases, okay? Now, as you notice, there is an example 3 in the book. We're actually going to skip that because that's something we're going to basically talk about later in another section, okay? So as of right now, these are the only 2 examples of questions that you'll have for this section. So being able to write graphs, tables, relations, so like example 1, and then example 2 here, being able to look at a situation and tell what the variables are and which one's independent and which one's dependent, okay? So with that being said, that's it for this section. Do be on the lookout for the assignments posted on Google Classroom. I'll also put a little thing on IXL so that way you can practice this kind of stuff on IXL. So that way you can be prepared and maximize your grade on the graded practice and graded homework, okay? So be on the lookout for all of that. Make sure, go over the notes here. But other than that, let me know if you have any questions, and I do thank you for watching.